All right, hi everybody. Thanks for coming. I'm going to share my screen here. Hopefully you guys will see it in a moment. Do you guys see my my slide there?
Yep.
Sweet. All right, well, I've only got a single slide here. The bulk of this presentation will be a demo. So my name is Joel Dice. I work at Fermion, which is a startup that is investigating using WebAssembly, not just investigating, but actually using WebAssembly for functions as a service types of workloads and other platform as a service cloud computing workloads. And so what I'd like to do today is guide you guys through a demo of creating a simple app using Rust, both on the client side in the web browser and on the server side in the cloud. So we'll implement a small backend and front end for an app. It'll be a little note-taking app. And so if, as a quick introduction here, for those of you who haven't heard of WebAssembly, it's been around since about 2015 in its current form, and was originally intended to run native code efficiently in the browser, specifically things like game engines and whatnot, which were commonly implemented in C and C++, and now in other languages such as Rust and Go, which target native code traditionally. And so WebAssembly is a way to run that in the browser as an alternative to transpiling to, say, JavaScript. And get some performance wins from that. And because of the strict security requirements of web browsers, namely you're downloading code from the internet and running it right there, it was designed from scratch to be a very efficient and lightweight sandboxing mechanism. And that happens to make it very useful in contexts outside of web browsers, including user-defined functions in databases, application plugins, serverless types of apps, edge computing, Internet of Things, anywhere where you might have a mix of code with different privilege levels, and you want to essentially restrict access to certain resources or information. And databases certainly fit the bill, especially multi-tenant databases. That's just kind of a quick introduction. WebAssembly, originally for the web browser, now finding its place in a lot of other arenas as well. And feel free to interrupt me if you have any questions. I'm going to go through this a little bit quick. This is sort of a condensed version of a longer talk that I gave a few weeks ago. But as a reference here, let me actually copy this into the Discord real quick. Let's see. This is the finished product that we're going to be kind of putting together. It's actually a fancier version of that finished product. But anyway, we'll get started here. So I'm going to switch over to my terminal here. And let's just clear this out. Get oriented here. I did a dry run here. Let me remove my work there. All right, so we're going to use two primary technologies to implement this. It's all going to be written in Rust, but it's going to use some SDKs. One on the front end, a front end framework called Leptos. There's a lot out there, just like in the JavaScript world. There's a lot of front end frameworks available. Leptos is one that's kind of gained popularity recently. If you're familiar with the JavaScript world, it's akin to Solid.js. So it's kind of like, to use a technical term, it's a VDOM-less front-end framework architecture. So it tends to be quite efficient. But there's a lot out there to choose from. They're all pretty cool. This is the one I'm happy to use here. So that's what we're going to use on the front end. And then on the back end, we're going to use a little tool called Spin. also written in Rust and then intended to host WebAssembly guests. And it's a command line tool designed to get you up and running quickly, building small serverless apps. So we're going to use that in our first step here. And that link I passed in there has links to download the prereqs if you're interested in following along. So I'm going to go ahead and get started here. The first thing we're going to do is we're just going to create a new app from a template. It's going to fill in some stuff here for us. Let's see what that gave us. So it gave us a cargo toml. It gave us a spin.toml, which we'll take a look at in a moment, is essentially tells spin about that application. And then it gave us just a small template, lib.rs. So let's actually look at that lib.rs. And it's pretty simple. So we're building a serverless app. And if you're familiar with, say, AWS Lambda or other serverless systems, the basic idea is you define some sort of trigger based on an HTTP request. And when an incoming HTTP request happens, a new instance, in the case of Lambda, a new VM, in the case of Spin, a new WebAssembly instantiation of a module happens, and then the request is passed into that guest, which exists in a sandbox with restricted access to the outside world, the file system, and so on. And then the guest processes that request, returns a response, and then that response is returned over the network to the original requester, to the client. To eliminate the noise here, I'm going to get rid of that print line. That's just printing out the request. So we've got our little app here. And we're going to go ahead and let's look at, actually, before we go any further, let's look at spin toml here. This is our little app manifest that got generated for us. Spin apps can be composed of one or more components, which is roughly are equivalent to different routes in your application, different endpoints in your backend application. In this case, we're just specifying a single component that handles all routes, as indicated by this line here. And then it includes information about how to build the WebAssembly, and then where to find the target of that build. So we'll go ahead and leave that alone for a moment, and we'll go ahead and run it, build and run it. After we go into notes here. So it went, grabbed our dependencies, built it. Oh yeah, I got rid of the print statement, so we've got an unused variable there, no worries. Okay, and then I'm gonna just quickly swap over to my web browser and we'll take a look at what we have so far. And it just, the text is pretty small there, but it basically says, let's see.
Guessing browser decided that wasn't happening.
Oh, okay. Well, so we'll just give him a minute to reconnect here.
Did we scare him?
I don't think that's what it is. There he is.
He
He's
probably
back.
got terribly offended when my Firefox crashed and it looked like I left.
He's back, everyone. It's fine.
Apologies for that. I must have hit some key combination that closed that browser window. That was especially poor typing on my part. Let me share my screen. We'll get right back to it. I will try not to type anything resembling Control Q. Let's see, allow. Okay. Okay, we're back in here. Okay. Can you guys see my browser window?
Yep.
Sure can.
Okay. Sorry about that. Okay. So we're going back here. So I was just trying to increase the font size, but of course that's very dangerous, apparently. I was thinking Control Plus, but that I'm not going to try that again. Okay, so all we really have here is just the simple hello world here. And it's not really that impressive, so let's go ahead and make it do a little bit more here. So at this point, we're going to add the client side of our application. So while I'm here in the notes directory, I'm going to go ahead and cargo new, myself a new project. It's going to be a bin project, binary project, so that means it has a main function, and we'll see what that main function looks like in a moment. Little warning about workspaces there. We can fix that real quick. Okay, so I am going to do a couple things. I'm going to edit my spin toml to tell it that we want access to the file system, limited access to the file system. So we're going to add a little something for the component. So as a reminder, you know, the whole idea with WebAssembly is similar to virtual machines or containers, is that by default, it doesn't have access to the host or its file system or its network. And so you need to explicitly grant access. And so that's what we're doing here. We're saying this directory should be mounted at the root of the guest file system. And then we're going to put some files in there. And then I'm going to create a little empty file here. We're going to use a tool called Trunk, which if you're familiar with Webpack or other bundlers, it's similar like that, but oriented to Rust WebAssembly apps. And it needs a index.html to run. It turns out that even an empty file is enough, but it doesn't need to exist. So we went ahead and created that. And then I'm going to add a little dependency here, which will allow us to easily add static file serving to our spin app. And so in here, I'm going to get rid of this hard-coded response, and I'm going to put in a little bit more intelligence. So this just says when we get a GET request for a path, we're going to see if there's a file in the file system, and if so, we're going to return it with a content type derived from the file extension or the file name. And then if we get any other kind of request, we'll just return a bad request status code. Call that good. And then I'm going to add a few dependencies to my client app. So we're going to, well, just Leptos for now. And by default, we need to enable the stable feature because by default, Leptos actually uses features from Rust nightly, and we don't want to mess with that at the moment. I'm going to go ahead and edit my spin toml one more time. And right now, the command out of the box from the template just builds the back end, but we want to build both now. So I'm going to add a little something here. Okay, so now this is basically what we had before, but before building the back end, we're going to build the front end. And like I said before, we're using this trunk tool, which will recursively invoke cargo and then do some fanciness in terms of generating some JavaScript boilerplate to load the WebAssembly that our Rust code compiles to. And if you're interested in more about that process, I encourage you to look at the Trunk website. And now that we have Leptos and a way to build it, we are going to edit our main.rs. By default, it's just whatever cargo new gave us, but that's not going to work on the web. We need to actually generate some HTML. And so some minimal HTML here looks like this. It's going to just create a top level text element in our HTML and fill in the body with that. So we'll go ahead and save that. And Then we've got to run that. So this is building both our front and back end here. Back end should already be built more or less, so should go pretty fast. Okay, and then if we reload this page, we see now we're actually serving content from, so this is now, the back end is being really dumb. It's just serving up static files, and that static file, those static files now include an HTML page, maybe a minimal CSS file that Trunk generates automatically for us, and some WebAssembly and a little bit of JavaScript to load that, to instantiate that WebAssembly. So Trunk kind of took care of all the details of that for us, and we're just left with producing HTML with the help of Leptos. So that's, you know, kind of cool, I guess, but we can do better than that. We actually want the front end and the back end to cooperate in a more interesting way. So let's switch back to our app here. Go ahead and kill the server for a moment, and we are going to edit our back end to make it do a little bit more. In addition to serving up some static content, I'm going to, I got to import one more thing. Spin has a built-in persistence key value store, which we are going to make use of here. And I'm going to paste in a little bit of code. So we're adding a couple more routes here. Really, I guess one route that you can both get and post to. The get route basically returns a value from the notes key in the key value store, and the post one does the opposite. It accepts a new value and writes it to the key value store. So we'll call that good. Head on out here. We do need to do one more thing. Again, because of the security model here, any resources that are available to the guests need to be explicitly granted to the guests. So we need to tell Spin about that. And we will do so here by saying that we are going to get access to the default key value store. And part of the reason here is if I had multiple components in my app, some of those components might be code that I didn't write myself, and I may not completely trust that code. And the beauty of the WebAssembly model is that I can actually bring that code in and properly restrict access to, you know, possibly sensitive resources such as my key value store, while still granting access to the components that I do trust. And I'm going to add a few more dependencies to my client app here. So this is adding just a few things for doing interacting with the DOM, the document object model in the web browser, doing requests in a Rust-friendly way, and interacting with futures, being able to do async await in a sort of fluent way in Rust. And now that I have those things, I'm going to go ahead and open my editor one more time. I'm going to get rid of that simple stuff. Actually, I'm just going to get rid of this whole thing, and I'm going to paste some stuff in here. This is going to be a big chunk of code, but I'll go through it pretty quickly for you just to give you a tour. So what we have up here is I've actually created a new function, and this is, if you're familiar with kind of the React or any modern front-end framework, I'm essentially defining a component which I can later use. We're calling this the notes component, and we declare some state variables that we're going to use down here. And then one of the first things we do upon mounting this component is send off a asynchronous request to the server to or to the serverless function, as in this case, to retrieve the existing notes if there are any, and then we're going to define a callback which we will reference in our HTML, which posts a new value to that endpoint that we created earlier to update the notes in the key value store. And then finally, we have some HTML, which will be dynamically updated by Leptos as the state changes, the notes change, for example. And then we have our on-click on our button that will invoke our callback. So hopefully, if you've done any front end work, this will seem pretty straightforward. Maybe the syntax might be a bit unusual if you're used to JavaScript, but hopefully the basic pattern feels familiar. So we'll go ahead and save that, and we'll build it. We'll see if I forgot anything here, but I think we should be good. Building our new dependencies. We're running. Oh, did I save? Let me see. Doesn't look quite right to me. I don't think I saved my changes. Yeah, something's wrong here. Okay. Beauty of live demos. I do have my notes here. Try that again. Okay, it's not doing what I was expecting, because now when we're asking for notes, it's actually giving us some WASM or some HTML. So it's giving us index.html. Mhm. Oh, I think I'm the ordering here. So this is pattern matching in Rust for you. I think I should have put it up here. Because yeah, the my git pattern here. If you're a Rust veteran, you probably would recognize this immediately. But this pattern is more general than this pattern up here, and so we need to order them in that way to get what we want. So let's try that again, and I'm hoping. Okay, now actually what we saved is actually what's showing up. So we'll go ahead and save that again. And then if we open a private window, just to kind of prove that it's not local state that we're dealing with here, we can see that it got saved and persisted. And if I opened up my phone or web browser or whatnot, we'd see it there. Okay, so one last thing while we're at it here, in addition to running it locally, we can also deploy this to Fermyon hosts a free cloud. If you have a GitHub account, you can get free access to this cloud and you can deploy apps there. So just to demo this running on the interwebs, we will deploy it. And now we have it running here. Did I spell Vancouver right? It doesn't look like it. Oh, well. And then if we refresh the page, we still get it. So that is it, and time flies. I think I'll wrap it up there. Any questions about what I went through? If you want to take another look at any files or anything else. Oh, it is the correct spelling. Excellent. Just need to capitalize it maybe.
The server side, what framework were you using? I think I didn't quite catch that.
Yeah, so it's a tool called Spin, and so it's
Spin is in the server side.
yeah, Spin is what we're doing server side, and so it's
Okay.
a serverless type of thing. So the idea is that you're not really
Right.
running a server per se, except for development purposes,
Mhm.
but instead, yeah, you're basically prototyping there, and then you're deploying to functions as a service sort of thing, similar to AWS Lambda, but WebAssembly based.
Yeah, okay, I get it now. Because I was like, maybe I missed where that happened. Okay, I get it.
No.
And
Sorry, go ahead.
no, you finish. Go ahead. It's okay. I'll ask another question after.
Oh yeah, so you said that this is serverless. So I mean, with that code that you showed us, can this be uploaded to AWS?
I think not as is. So each part of the challenge with the state of functions as a service right now is each vendor has its own API and its own set of languages which it supports. I'm not actually totally current on what Lambda supports, or Google Cloud Functions, or Cloudflare workers. They all have their different sets. Some are more JavaScript oriented. Some let you branch out to other languages. And unfortunately, because they each have their own APIs, you can't really just take one written for one and work on the another. One of the goals in the WebAssembly community is, and I see Joe is on the call here, he could tell you more about this, is to create a standard set of APIs for cloud computing, which would allow you to run, which is intended to be vendor agnostic. That's still in the early days. We're working on prototype support in Spin and in Fermyon Cloud to support that. But right now, it's unfortunately, we're just sort of in a way adding to the problem, in that we do have a proprietary API that you have to adhere to if you want to. I say proprietary; it's all open source, but it's one that we made up and have not tried to standardize. But like I said, we're trying to move to a standard that is vendor agnostic.
Oh, okay, but at least you can like push it to that free cloud service. Okay, thank you.
Sure.
I think there was another question in the chat from Edward Naidu. I'm not really sure how to pronounce that. Saying, what's the difficulty level? I'm not sure what that's in relation to.
Oh yeah, let me check the chat here. I should have that open. What is the difficulty level? Yeah, maybe a little clarification on that. I mean, I hope the demo. Oh, good.
I was just clarifying. I think he sent a follow-up saying that he was asking for difficulty level regarding to this project. The one that you just showed, I imagine.
Oh yeah. I guess it depends on where you're starting from. And you can definitely check out the link. Let me paste it in the chat here while we're at it. But to the finished product, which actually the finished product's fancier. I actually do end-to-end encryption of the notes, just because it was fun. But let me see where. Gonna get a peek at my Google Drive here. Try and get back to presentation.
Copy the link if you like, actually.
Yeah. Okay. Yeah. Thank you. So yeah, I would say the difficulty getting started with Leptos. I think that the bulk of the code we went over here was actually Leptos, and Leptos it's a bit of a learning curve. Again, it depends on what your background is. If you're familiar with Solid.js or even just React, any of the front end frameworks. Yeah, thank you for pasting that in. Then you should feel relatively at home. But if you're new to Rust or you're new to front end, modern front end frameworks, then learning one or both at the same time is going to be more of a challenge. So, yeah, it just depends on where you're coming from.
All right, I'm actually gonna stop the questions period here. If you have more questions, I don't know if Joel, if you're going to be able to stick around until after the next presentation, but if you have time, then yeah, you can probably ask some more questions after. But I want to give time to our next presenter. I believe it is Treva. I'm not really sure how to pronounce that. Are you here?
Hello, I'm here. It's Shiva.
Treva, okay. Thanks. Also, are you okay with your talk being recorded as well?
Yeah, absolutely. But my camera's being weird right now, so I'm afraid that my image is just going to be air Tubman, if that's okay.
That's fine. Yeah, you can just share screen, and that should be good enough.
All right. Let me see if I can figure this out. I hope everybody's having a good week.
Yeah, it's a hot week right now in Vancouver, but things are going pretty good.
So that's the fascinating thing. I'm on the East Coast, and we are under a freeze watch right now.
Oh wow, that's different.
Share a window. Hold on just 1 second. I'm almost got it. Maybe. Okay, am I showing?
I
Not.
don't see it yet.
All right, trying one more time. I believe that I'm going to have to stop and rejoin. I apologize for this, but I will make my presentation fast so we can get back to questions. I'll be right back.
All right. Um, I guess in the meantime, uh, we got another question in the chat, I guess. Oh, and
Yeah, I just answered in the chat. I think the question was, if I am interpreting it correctly, whether the products of the trunk build were served up by Spin. And yes, that's correct. We basically set it up as one of the first steps as a file server with a few lines of, request routing code.
okay. I guess if anyone else has any other questions, then feel free to ask them now. Or people comes back. Any no questions? Oh, we got one question. What got you into learning Rust? Is that a general question for everyone, or?
I can give my story, but yeah,
Yeah,
happy
go
to hear
ahead.
others as well. Yeah, well, my background, I've spent about 20 years doing C++ and Java primarily, and initially was a little turned off of Rust. I was, not sure if kind of the overhead of the bar checker and the sort of the syntax was my cup of tea. But oh yeah, it looks like we've got. I'll cede the floor here, but then a friend convinced me to give it another try, and I've been hooked on it for the past 5 years, and would not reach for anything else for most projects.
All right, Triva, we can see our screen now. Everything seems to be good. Floor is yours.
We can see, but can we hear?
Oh no.
Technology is good at this.
Yeah, no microphone.
Oh, and I don't think she can hear us.
Oh, that's even worse. Hope she has the chat open. Hang on, I might send a message.
Right.
I just fired off a message. Hopefully that
All right, if I'm still muted, I'm going to cry. Can you hear me now?
We can hear you now.
Hooray! Okay, now let me try the screen share again. All right, third time's the charm, huh?
Alternatively, you could do the screen share and how you got it working a while ago and use your cell phone to call in. Oh, never mind. We got both.
Okay,
All right.
we're in business. Thank goodness.
All right. So that was an ordeal. So you will never believe what my role is, but let's go ahead and jump into it. So hi everybody, Vancouver Rest Stations. I was really excited to get that off, but now I got to rush past it. My name is Shriva. I am a technical community manager for Open Infra Foundation, even though you would never believe the technical part after all of that. I hope you will hold it against me. Open Infra Foundation was formerly known as OpenStack Foundation. Now, OpenStack/Open Infra Foundation started in 2012 to support the OpenStack project, which at the time was only 3 projects. Nova, Keystone, and Swift, created by Rackspace and Nova, but that has since expanded, meaning OpenStack, to dozens of groundbreaking projects that revolutionized infrastructure as a service. So in addition to incubating OpenStack, growing it to become one of the top 3 most active projects in the world, the foundation also holds yearly summits and project teams gatherings. From here on will be described as PTGs because that's way easier to say, as well as hosting OpenStack Days, which are one-day events all over the globe to bring the community together in person. We also have an extensive web presence for those still reluctant to travel, specifically Open Infra Live. This is where developers, users, contributors, and other thought leaders in the Open Infra community can share the latest news with their projects, create something of a history archive, and a whole lot of other things. You can check that out on YouTube if you got a few minutes free. TLDR, we're a very small and very close-knit group of tech enthusiasts who love all things open. And as a quick plug, I'm sure you're all aware, but we're going to be in your neck of the woods June 13th through 15th for Open Infra Summit and PPG. And it'd be really swell if you came and stopped by and visited us, specifically the Kata Containers group, because we will be there deep. Anyway, every good organization, group, company, or foundation has a theme, and Open Infra Foundation is no exception. Our theme is open source, or our themes are open source, open design, open development, and open community, otherwise known as the 4 opens. So every project that we host has to commit to follow the 4 opens, with the first being obviously open source, which means that anybody should be able to study your program, modify it, and redistribute either the original or the modified version so that others can benefit. The next one is open design. Open design guarantees a transparent and open process for planning and designing software. This is about letting go of control of the design of the software and its feature roadmap and accepting that it should be driven by the community. Next up, open development. This refers to the adoption of transparent and inclusive development processes that enable everyone to participate on an equal and level playing field. Publicly accessible services means that everyone can see everything about development activities without needing to sign up for a service. It also means that all patches are welcome for consideration, whether that patch is from a project founder or a first-time contributor. That is what we call drive-by contributors, and we love them. But anyway, don't want to go off on a tangent. The last one is open community. And this is about ensuring that the community has a cohesive, inclusive, and level playing ground where all voices are heard and anyone can rise to leadership positions. Now, to build a truly open community, you need to balance the 3 forces illustrated in the middle there. 3 forces are developers, users, and ecosystem. It's important to establish common goals and build strong connections between those forces, because operating in silos dilutes the power of the overall community. Each force, whether they believe it or not, affects the others, so they have to work in harmony to achieve their goals. All right, let's get back on topic a little bit. In addition to being the home of OpenStack, which we all know infrastructure as a service, is super, super awesome, we also host a bunch of other projects, including Airship, which is an open source project that provides tools and methodologies for automating the deployment and management of cloud infrastructure. It integrates with Kubernetes and supports the entire lifecycle of infrastructure from provisioning to ongoing operations. There's Starling X, which is kind of like an all-in-one toolbox designed to help organizations deploy and manage edge computing infrastructure. It offers various features and components that make it easier to run applications and services in remote or distributed applications, such as factories, retail stores, or telecom towers. It's pretty popular with telecom. There's also Zool, which is an open source CI/CD platform originally developed to support OpenStack that's grown in popularity as of late. Now, what Zool does is it manages complex and distributed testing and deployment workflows, provides a powerful automation toolset for setting changes across multiple repositories, enforcing gatekeeping policies, and orchestrating the integration and development of software changes. There's also OpenInfra Labs, which is a little bit different. OpenInfra Labs is an inclusive and collaborative initiative that encourages experimentation, collaboration, and innovation in the field of open infrastructure. It provides a platform for testing, developing use cases, and fostering community engagement to enhance open infrastructure technologies. And last but certainly not least is Kata containers, which is the reason why we're all here, and it's the kernel, the container with the kernel in it. So what is Kata containers? It was originally born from the merger of two formerly existing open source projects. That was Intel Clear Containers and HyperRunV. What Kata Containers does is it brings together the best of both of these technologies with a common vision of retooling virtualization to fit container native applications in order to deliver the speed of containers and the security of VMs. It benefits from each of those projects' strengths. While Clear Containers was focused on performance and enhanced security, HyperRunV prioritized being technology agnostic by supporting many different CPU architectures and hypervisors. By merging the projects, Kata Containers delivers a superior end-user experience in both performance and compatibility, unifies the developer communities, and accelerates feature development to tackle future use cases. So how does it work? What it does, or what Kata Containers does, is it helps to improve security and isolation of software applications running on a server by using lightweight virtualization. Now, normally, when you run multiple applications on a server, they all share the same operating system. That's what we're used to, right? Which means that potentially a bad actor on that same host could potentially interfere with one of the other hosts or one of the other guests and potentially access their workload. But with Kata Containers, each application runs in its own tiny virtual machine or a container with a kernel. And each container has its own isolated file system, memory, and network along with that kernel, which means the applications running inside them are protected from each other. It's kind of like having separate rooms in a house where each room has its own furniture and belongings. I like silly analogies, so I had to throw that in. Anyway, Kata Containers also provides extra security features by using hardware virtualization technology to keep containers separate and secure from the underlying hardware, while also isolating the network stack. So even if one container is compromised, it's difficult, if not impossible, for that compromised or infected container to affect other guests on that same host. So to simplify it even more, because I like saying things in simple ways, Kata Containers makes little virtual machines for each application, keeps them separate and secure from each other. And this helps to prevent one application from affecting or accessing another application's data, providing better security and isolation. Hooray, we all love that. So all right, let's talk about the Great Rewrite, which is the reason why you invited me here today. In the beginning, Kata Containers was primarily written in Golang, with a few other languages sprinkled in here and there, including but not limited to Bash, which is my favorite go-to because it's super easy and it's what I started with. Not talking about myself, getting back to Kata Containers. While Golang excels in simplicity, from what I've heard, ease of use, and rapid development, Rust offers control, safety, and performance optimizations, which of course would be alluring to developers maintaining a hyper-secure container runtime. The transition from Golang to Rust began during the 2.x release, starting with a switch to Rust Agent for higher container density and better memory overhead. At the release of Kata 3.0, Kata runtime was fully Rust-based, with more Rust features introduced with every minor release. In addition to hundreds of contributors from organizations like Alibaba, Red Hat, of course Intel, and the many unaffiliated but still very much appreciated and dedicated folks who keep the project growing, the Kata Containers community has a mentorship program fostering students from Boston University and North Dakota State University. For now, we're hoping to expand that, introducing them to the world of cloud-native technology through Kata containers, and of course, teaching them Rust. Go off on a little bit of a tangent. Our last mentorship program, which just concluded about 2 weeks ago, our mentors taught 5 NDSU students Rust from the ground up, and that was a very fascinating process to watch. That was really cool. Okay, getting back to it. So what made Team Kata decide to get Rusty? So some of the most attractive features of Rust include, but are not limited to, and I'm not going to sing too much praises to a bunch of Rustaceans about Rust, but I'm going to talk about it a little bit. Memory safety. Rust is designed with a strong emphasis on memory safety that enforces strict rules at compile time to prevent common programming errors like null pointer deferences, buffer overflows, and data races. This helps in writing safer and more reliable code, especially for programming in applications that require high performance and low-level control, Kata containers in a nutshell. There's also the benefit of concurrency and parallelism. While both Rust and Golang have built-in support for concurrency, Rust offers fine-grained control over thread safety through its ownership and borrowing system, which allows safe sharing of data across threads without sacrificing performance. Rust also provides tools like asynchronous programming with its async await syntax, enabling efficient and scalable concurrent code. There's also the performance benefit, which is pretty obvious. Rust's focus on zero-cost abstractions and low-level control allows developers to write high-performance code. It offers predictable performance characteristics and efficient memory management, making it suitable for resource-constrained environments or applications where performance is critical. There's also safety and reliability, which is a major selling factor for Kata containers. Rust's ownership and borrowing system, along with its static type checking, helps to catch bugs at compile time, reducing the likelihood of runtime errors, which our enterprise users very much appreciate. This promotes safe coding practices and encourages developers to handle errors and edge cases explicitly, which leads to more reliable software with fewer unexpected crashes or vulnerabilities. There's also ecosystem and tooling. Rust has a growing ecosystem of libraries and tools that support various domains, including web development, networking systems, programming, and more. The package manager simplifies dependency management and provides a consistent and streamlined development experience. And in addition to all of that, the documentation and community support are also highly regarded and quite famous, which is something that the Kata community also prides itself on. So it was only fate that we connected. Now, if all of this stuff sounds appealing and you want to get involved with the Kata community, which I very much hope that you do, there's a bunch of ways to do that. Kata Containers is released under the Apache 2 license, of course, following along with the 4 opens, and it's hosted on GitHub. Anybody can contribute code, docs, reviews, issues, feature enhancements, anything that you think would enhance the project. You can do that over on github.com/Kata Containers. That's where you'll find everything and everyone tied to the project. I hope that you go and visit. there. If you want to get a hold of a Kata herder, to ask some questions, or maybe share some answers, or maybe just make a new friend, the best place to do that is the Kata Containers Slack channel, which can be found at katacontainers.slack.com. This is where we chat throughout the week on project news and just link up with one another for a geeky conversation sometimes. If you're more of an IRC person, you can find us on OFTC at Kata Dev, and this channel actually hooks into Slack, so you'll be able to reach all the same folks, just on a different platform if Slack's not your thing, which I totally understand is super heavy at. So anyway, I couldn't get the link on the page in a way that made it easy to understand, but if you're more of a face-to-face communicator, join our weekly architecture committee meetings, which happen every Tuesday at 1500 UTC. I'll put the link for that in the chat after I'm finished talking. I can't multitask. But anyway, that's where we share feature updates, project updates, release notes, conversations about what's going on with the community, share potential abstract opportunities or some abstract submission opportunities, all that fun stuff. Sometimes we just talk about like cake stuff. It's a fun meeting. So if you have that time free on Tuesdays, I highly encourage you to join. Or if you're not able to join, I'll post a link to our agenda, which actually has an archive of all of past meetings as well as notes. So you can just read along if you don't have time to join in the video. Now, if for some reason you want to get a hold of me, I don't know why you want to do that. You can find me on GitHub and most of the socials as OG Trilliums. That's Mastodon, Spoutable, the Bird app, pretty much everywhere. And there's also LinkedIn. If you're not a social media type of person, just linkedin.com/Trilliums. That was one platform that I couldn't find OG Trilliums for some reason. Or maybe I already have an old account. I don't know. That's pretty distinct. I don't know anybody would want that. But yes, OG Trilliums. I am all over the internet. Or if you want to meet me in person along with my dog, we will be in Vancouver next month. So if you see somebody running around in a stupid dress with a dog, that is most likely me, and I will be very happy to meet you. And my dog will too. So with that, I very much appreciate you all hanging around this late at night. Thank you all so much for the invite. I hope that made sense and that you enjoyed the presentation. And I also hope that you have a great week, but this is where I will start taking questions. And let me post that link while I'm thinking about it.
I have a question.
Sure.
So did I see on one of your slides that Kata uses Firecracker behind the scenes? Is that accurate?
Yes, that was incorporated in Kata 3.0 along with Dragon Ball sandbox support.
Cool. Do you and your cohorts contribute upstream to Firecracker as part of your work?
I think at least one of them does.
Cool.
Sorry, go back to my page.
We also have a question in the chat.
A question in chat about using AI tools in your work. That is a great question. And it is a very timely question. As a matter of fact, I can't share too much details right now, but I am hearing news from Open Source Summit North America that Kata Containers is being used in some AI work. I am in the process of finding out more about what they're doing, but a shorter way to answer that question in a non-rambly way, yes. I'll expand that to say if you join our AC meeting next week, you might be able to hear a little bit more about it. I don't know, hint, hint. Any further questions?
Going once. Going twice. All right. Wait.
I think Peter's trying to talk. Peter, you're very, very soft.
Sorry,
Yeah,
do, you,
quiet.
do you deal with kernel internals much? Because I'm hearing that Rust ownership doesn't suit some of the kernel internals because of multiple ownership, linked list, hash tables, what have you.
I'm gonna repeat to make sure that I understood you. You asked about kernel ownership.
I'm wondering if you are hacking into Linux kernel in Rust or
Oh.
planning to.
That is a great question. And unfortunately, I am not super positive about that. But that is something that I think I'm going to ask the community. And I hope that there is a way that we can follow up because I would love to answer that for you. Would you mind emailing me or like catch me on Slack or Twitter or something? Because I definitely want to find out more about that and maybe write an article about it.
Yeah, I'll email you. I was curious because even though Rust is in kernel now it's mostly for, well, I think so far it's only for modules, and there are parts of kernel that it doesn't make sense to use Rust.
I see where you're getting at, and now I am curious and fascinated too. So yes, that's something I definitely like to explore. Unfortunately, I can't give you an answer right now, but it's something that I would like to have answered in the near future.
Thank you.
Sure, thanks.
Maybe if she sends the answer to Peter, you could repost it in the Discord for the rest of us, because I'm kind of curious what the answer would be as well.
Right? Yes,
I will.
absolutely. That's something I'd love to share with you all.
Any other questions? Comments? Concerns?
Criticisms?
Well,
No, please don't share those all.
More of a, I'm not sure what to call it. I'm not sure if it's, yeah, I think it's a question. Is it something that you can run on like a instead of using VMware? Is that something that you could use internally in your organization? Like host it yourself?
Oh, absolutely. Yes. You can run it on Kubernetes. You can run it bare metal. You can run it in VM. Basically, anything that will support nested virtualization, Kata containers will run on.
So if you want to do a bare metal install, is there an installer on your website that you would try out? How does that work?
Say that one more time.
So if somebody wanted to test out running a bare metal, is there an install on your website? Do you have a list of supported hardware? What's this arrangement like for that?
Yes, it is actually on our GitHub. Let me see if I can find the link for you. But see, getting started, maybe this is the one. So our doc site, that is a task that I am assigned. We are currently revamping it, but for right now, everything is a little bit scattered, but everything that you would need to find as far as getting started in installation is going to be on GitHub. And of course, if there is something that you can't locate, just like hop on Slack or send an email to Kata Dev, and either I'll see it or another Kata herder will see it and we'll point you in the right direction.
Okay, thank you very much.
Sure. But I just want to throw in that installation is super easy. The code base itself is just like headache inducing complex, but install is like you'll actually be pleasantly surprised with how easy it is to install and how easy it is to run.
All right. Do you have any other questions? Last minute questions? Comments? Concerns? I know it's getting kind of late right now. So. All right. Well, if there aren't any other questions, then there are a few things I want to actually quickly go over here. Again, as usual, if you want to do your own presentation at our meetups, feel free to message either me or Chester. We're available on Discord. as usual, or you can just message us on Meetup or fire off an email, and we can help you get set up here. And another thing I wanted to talk about was the what's going on with in-person meetups. So yeah, we're actually getting very close to being able to have an actual physical venue. And as I've been saying, we're going to be running our events as hybrid events. So if you still prefer to join virtually, you can still do so. That option will always be available. But starting maybe even as early as next month, we'll be running events in our office. And that means that we may be able to have meetups in our office. I'll have to check with HR and management at my company, but yeah, we might be able to finally have in-person events again. So if you're looking forward to that, then yeah, it might be coming a little bit sooner than you expect. And the last thing I really wanted to talk about today was the poll. So that was actually a mistake. So if you joined or if you RSVP'd for today's meetup, you'll probably notice that we still have the Google Meet versus Discord poll. That was a mistake. I didn't mean to leave that up. I actually didn't realize that would still be up. I'm gonna do that after today. But yeah, the results there aren't going to influence anything right now since we literally just did the poll and announced the results. I don't want to. I think it's a little too soon to just be like reversing decisions right now. So I just want to let everyone know that while I will add up the votes for today's meetup and take that into consideration, I won't be making any changes based off of them. So yeah, that's pretty much it. Other than that, I just want to give the usual thank yous to Improving. That's the company I work for sponsoring these events. They pay the meetup fees. It's like over $130 or something like that. It's not exactly cheap. So yeah, it's very, very nice of them to do that. And I want to give a shout out to Chester, my co-organizer here, for providing the Google Meet room, because otherwise we wouldn't really have a room more. Yeah, we'll leave the floor open for questions, comments. I see a question from Michael. Is it easy to find parking near the office? We do have a parking lot in the back behind our office, but yeah, I don't know how parked up it's going to be. It depends on like the other businesses nearby using it as well. But I think that it shouldn't be too hard to find parking, but yeah, you might have to like scope it out for yourself to see. Unfortunately, I can't really answer that, especially because I haven't been to the office in quite a while. Does anyone else have any questions, comments, concerns, anything they want to talk about? Like once, like twice. All right. Okay, we have a question. Do you have any experience in IoT? Short answer, no. Long answer, no. I don't know if anyone else here has experience with IoT with Rust, but I don't.
I sort of do. I used to work at a company that made an appliance that kind of allowed you to wirelessly share access to a display, say in a conference room, like a projector or a big screen TV or whatnot. And that was running sort of an ancient version of Android, and we kind of designed our own hardware for it and whatnot. So I don't know if that counts, but we did use some Rust in that, particularly with respect to monitoring via MQTT.
Was there a follow-up to that, or is this just trying to see if people here have experience with IoT? Edward. Give maybe a minute here. Okay, what is your experience with IoT with Rust?
I guess that's directed at me. Or
I guess.
okay. Okay. Yeah, it sounds like Michael has done a little bit. Yeah, I mean, for me, it was quite positive. We had limited hardware that we were working with, and pretty tight memory constraints. And Android tends to be Java native or Kotlin native these days, and but it was for both performance reasons and also to get access to kind of low level features like be able to mess with the Wi-Fi network and whatnot. You had to kind of go down into native code, and doing that in C, has all the hazards of C, and being able to do it from Rust, and wrapping the hazardous parts in unsafe blocks and kind of treating those with special care and leaving the rest of the code safe. Had some advantages in terms of maintenance and avoiding data races and whatnot. So for me, it was a breath of fresh air again, coming from C++ and C, where it's like every line of code seemed to be a minefield. So.
Right. Looks like that answers his question. Is there anything else that anyone wants to talk about, or shall we end for the day? All right, nothing? Okay then. Well, thank you all very much for coming. We had a lot of people drop by today. Very, very grateful for that. And I'm grateful to both of our speakers for taking the time out to come to our meetup, even though this wasn't the original plan. Sorry we couldn't get the in-person venue in time, but soon. Yeah, I will stop the recording now, and I will. Yeah,
Thank you. See you.